Welcome to this video. In this video, we are going to learn about the design of experiment. Design of experiment primarily serves two purposes. One is it allows to collect the data. The design of experiment primarily serves two purposes. One is it allows to collect the statistics of the response. Collect the data. If we go back to our probability distribution, we are using probability distribution concept. It arises quality loss function. Quality loss function. First, we want to collect the data and we choose the sample from that and construct the design. For example, select 5 candidates from each year. From first year 5 candidates, from second year collect 5 candidates, 5 candidates from first year, again 5 candidates from second year, again 5 from third year, another 5 from fourth year. From each department, we want to collect each 5 candidates. So, 16 times 4 years, imagine there are 16 departments. Okay, now totally we have from first year 5, second year 5, third year 5, fourth year 5, totally 20 students. This is for one department. Similarly, for 16 departments, we have 320 candidates. Over, we have 320 students. After collecting this information, we want to use any type of distribution. Most oftenly, we are using normal distribution. For solving normal distribution, we want two parameters. One is mu and sigma. Mu and sigma. Without knowing this mu and sigma, we can't solve normal distribution. Okay. In order to create this data and take this parameter is nothing, but our statistics follows the design of experiment. Follows the design of experiment. Can let we do. Okay. From collecting these informations, this methodology is called the design of experiments. This design of experiment is the collection of attributes. In our example, it is something about the department, gender, year. These features, whatever it is, we get some output. Our inputs are the gender, year, department. We get some output. For repeating this process, we get different answers or different outputs. This is called an experimental. This is called an experiment. Okay, design of experiment is a systematic approach to determine the relationship between factors that are affecting a process and the output of that process. In other words, it is used to find the cause and effect relationship. Cause and effect relationship. This information is enough to manage the process inputs in order to get the optimize the output. All the experiments are designed experiments. All experiments are designed experiments. It is just that some are poorly designed and some other well-defined experiments. Some are poorly designed and some are well-defined or well-designed. Okay, all the experiments are designed experiments. It is just that some are poorly designed and some are well designed. In production and quality control, we use design of experiment that is used to control the error and optimize the output process. From an engineering perspective, we are trying to use experimentation for the following process. First one, reduce time to design. Reduce time to design or develop the new products. And processes. Second one, improving the performance of existing process. Third one, improve reliability of the process. Improve reliability and performance of the products. Fourth one, achieve product and process robustness. Fifth one, perform evaluation of techniques. Perform evaluation techniques and materials, design, alternatives, setting component and system tolerance. Etc. In these categories, we are using the design of experiment. Okay, we always want to fine tune or improve the quality of the product. In today's global world, this drive for competitiveness affects all of us, both as consumer and producers. Every experiment design has some inputs. For example, cake baking, we have our ingredients like sugar, flour, milk, eggs, etc. In every experiment, there are inputs, and in addition, there are factors such as time of baking, temperature, and geometry of the cake pan, some of which we can control and others that we cannot control. In that cases, we are going to apply some experimentation. Experiments are performed by investigators in virtually all fields of inquiry, usually to discover something about a particular process or system. We can define an experiment as a test or a test series in which purposeful changes are made to the input variables of the process or system, so that we may observe and identify the reason for changes that may have occurred in the output response. Okay, the design of experiment includes the following categories. One is planning of the experiment. Second point, obtaining relevant information from the process or from the experiment. Obtaining relevant information from the experiment. Regarding the statistical hypothesis under study. And making the statistical analysis of the data. Making the statistical analysis of the data. Evaluation of material alternatives. Evaluation of material alternatives. Next point, determination of key product design, parameters that impact performance. Okay, these are the some application that includes the design of experiments. Okay, usually design of experiment in this area can result in improved manufacturability of the product, enhanced field of performance of the product and reliability, lower product cost and shorter product development. Okay, now we want to discuss about the basic terms and definitions. Experiment. An experiment is a device or a means of getting an answer to the problem under consideration. It can be classified into two categories. One is absolute experiment. Second one, comparative experiments. Okay, absolute experiment consists in determining the absolute value of some characteristics. Okay, for example, obtaining an IQ or the average IQ, obtaining the average IQ of a group of people. Second one, comparative experiment. It is designed to compare the effect of two or more experiments on some population characteristics. Example, comparison of different fertilizers, different varieties of a crop. Next one, treatments. Various objects of comparison in a comparative experiment are termed as treatments. Example, in a field of experimentation, different fertilizers or different varieties of a crop or different method of cultivation or the treatments, different method of cultivation or the treatments. Next one, experimental unit. The smallest division of the experiment material to which we can use the treatments and on which are make observations on the variable under studies is termed as experimental units. The smallest division of the experiment material to which we apply the treatments and on which or make observations on the variable under study is termed as experimental unit. For example, in field of experiment, the plot of a land, this is field of an experiment. We consider only the plot of the land is called an experimental unit. Blocks. In agricultural experiment, we consider most of the time we divide the whole experiment unit, that is whole field, into relatively homogeneous subgroups. These subgroups which are uniform amongst themselves, than the field as a whole are known as blocks. Okay, the experimental field can be divided into homogeneous subdivisions. Okay, these are called blocks. The measurement of the variable under study, the experimental unit, on different cases. Example, plot in the field of experiment is called yield. That is the measurement of the variable under study on different experimental units. Example, plot in the field experiment is called as yield. Experimental error. The variation from plot to plot caused by uncontrolled factors. That is experimental factor the variation from plot to plot caused by uncontrolled factor. Okay, for example, the natural differences in fertility which brings variation. Okay, the variation from plot to plot caused by uncontrolled factor. Okay, that may be difference in fertility, or there is a nature differences in fertility which brings the variation. Now, basic principles of experimental design. According to the Professor Ronald A. Fisher, the basic principles of the design of experiments are: first one, replication. Second one, randomization. Third one, local control. Okay. According to the Professor Ronald A. Fisher, the basic principles of the design of experiments are replication, randomization, local control. Replication means repetition of the treatments under investigation is known as replication. That means the execution of the process takes more than one time. That means the execution of an experiment take more than once. In replication, we get more reliable estimate than it is possible with a single observation. Randomization means it is a technique by which we can randomly assist the treatments to the experimental units. The purpose of randomness is to ensure the treatment is unnecessary, favored or handicapped. Local control, the process of reducing the experimental error by dividing that relatively blocks is known as local control. It increases the efficiency of the experimental unit by reducing the experimental error. It increases the efficiency of the design by reducing the experimental unit. It increases the efficiency of the design by reducing the experimental error. ANOVA, that is analysis of variance, that is the separation of variance ascribable to one group of causes from the variance ascribable to another group, which is called the analysis of variance, a short form ANOVA. Essentially, analysis of variance provide a test of homogeny of a set of data. The aim of analysis of variance is to feel how much the total variable is due to each factor, and by comparing these contributory amounts of variation, we can test the homogeneity of the observation. Assumption for analysis of variance of test. We have the following cases. The first point, sample population is normal. Second point, the treatment's effects are addictive. Third point, the individuals have been randomly selected from the population. And fourth one, the variance between the samples is consistent. Fifth one, the experimental errors should be homogeneous in their variance and are independent. Next, we have followed some techniques based on ANOVA. There is one-way classification, two-way classification, three-way classification. One-way classification, we named it as completely randomized design. Two-way classification is called randomized block design, and three-way classification we named as Latin square design.